channel. In this lecture, we are going to discuss about the photodiode. So what is a photodiode? Photodiode is a semiconductor device that produces electric current when exposed to radiations, when exposed to especially photons. So when we go to the symbol of a photodiode, it resembles the symbol of a PN junction diode, where one difference is the arrows are pointing towards the photodiode. There are other two diodes which resembles the symbol of a photodiode. They are laser diode and light emitting diode, with the difference that the arrows will be pointing outwards. It means those two diodes are capable of emitting radiations or light, and this diode is capable of accepting radiations or light intensity of various ranges, so that it produces electric current. So when going to the construction and working, let's see that the construction is similar to that of a PN junction diode. So in PN junction diode, the P type will have holes and N type will have electrons, and there will be minority charge carriers. In addition to that, there will be electric field developed in the depletion layer. So this electric field is developed near the junction. When reverse biased, what happens in photodiode, and in both photodiode and PN junction diode, a small amount of reverse saturation current is produced. So it is called as reverse saturation current in PN junction diode, and it is called as dark current. If you can see here, it is called as dark current in photodiode. Here from 0 to -5, if the voltage is increased, a small amount of current is produced. This current is called as dark current because there is not yet no radiations emitting on the photodiode. Now what happens is, in addition to the reverse bias, and due to that reverse bias, there is a small reverse saturation, this small dark current produced in the photodiode. Now when this photodiode is made to incident, when photons are made to incident on this photodiode, what happens? Additional electron hole pairs are generated. Additional electron hole pairs are generated in the depletion region, so that there will be charge recombination in the depletion region itself. So in addition to this process, what happens is, with the help of the electric field, these free charge carriers, free electrons and holes, start moving towards the supply. So electrons get attracted to the positive terminal and holes get attracted to the negative terminal. By this, the dark current, by which the current is made to increase, along with the reverse saturation current, due to the movement of holes and electrons, what happens is the current is increased. In the reverse bias itself, photodiode is able to produce current. So this is possible. The magnitude of current depends upon the intensity of the radiation incident on the photodiode. So for example, if 100 lux is the luminous intensity, it is the intensity of the light. Unit of intensity of radiation is the lux. So that if 100 lux is incident on the photodiode, what happens is 100 lux is incident on photodiode, and at the same time it is reverse biased. The current will increase up to a certain point, after which it does not increase and it will remain constant. This is due to the intensity of radiation. So if we increase the intensity of radiation and increase the reverse bias, the current will increase to a certain point. For example, this is 100 microamps and this is 200 microamps. So when we increase the reverse bias voltage, what happens is, for 100 lux, when we increase the voltage, the current becomes constant at a certain point. Though we increase the voltage, current does not increase. Similarly, for 200 lux, the amount of intensity of radiation, we increase the reverse bias voltage, and at a certain point the current becomes constant and the voltage increases. So as we increase the intensity of radiation, the current increases. The current increases based on the intensity of radiation and becomes constant, and the voltage only increases. So the idea is, when we increase the intensity of the radiations that are to be incident on the photodiode, the current increases.